Good morning, my dear friends. So now, in the last class, we have tried to find out the ultimate moment of resistance of a rectangular beam. Okay. Now, in this class, we'll try to see if the beam is a flanged section. Like say now, it may be a T section. Okay. It may be a T section or it may be an I section. Okay. In such cases, how to find out the ultimate moment of resistance of a PSC beam. Okay. See now, Baba, please try to now understand now this one. Okay, here I have got a T section now. Okay, I have called this as a BF in the sense of breadth of the flange. This as a BW, it is the breadth of the web. Okay, area of steel here is now there. Is now total area of steel is AP. Okay, so now this is your overall depth capital D. This is your effective depth small d. This is your neutral axis. Okay, neutral axis depth is now XU. XU. So now I will call this depth of the flange or thickness of the flange as DF. Okay, DF indicates the thickness of the flange. Okay, so now here you have got two things now. One is, suppose now here, if the neutral axis lies in the web, okay, now it is the story is entirely different. If the neutral axis lies in the flange, okay, you can use the same equation as we used in the last time for the rectangular section. Okay, at that time it will act just like a rectangular section only. But if the neutral axis lies in the web here, something like this, whatever I have shown here now. Okay, now the analysis is different. Okay, now we'll try to see now. See now, for this web portion, I have taken it from here. This complete thing I will call it as the web. Okay, this complete thing I will call it as the web. Okay, for this web portion, I can draw the stress block. The stress block for the web portion is just as you did in your previous case. Okay, so the this thing is now rectangular parabolic stress block. Okay, rectangular parabolic stress block. It is 0.45 FCK, absolutely no difference at all. Okay, so now TU force can be written as FPU into APW. APW is the pre-stressing steel required for the web portion. Okay, so now see now here I will call it as AP. AP is now split into APW and APF. Okay, sir. Now see now I will show you that one little bit. Okay, see now your AP and then total area of pre-stressing steel can be split into APW plus APF. APW means it is the area required for pre-stressing area required for the web portion. Here it is pre-stressing area required for the flange portion. Okay, so APW plus APF will give me total AP. Am I right, sir? No. So now, so with this, now we shall proceed now. See now, see now here this stress block for the web portion remains same as you have seen in your last case. Okay, so I can write here the only change is TU force, ultimate tensile force in the pre-stressing steel is FPU into APW. Okay, because it is in the web portion now. APW means it is the steel required for the web portion. Okay, so now similarly I want to find out CU force now. Baba, CU force can be written as usual. This is the average stress. Average stress is 0.36 FCK. Okay, and it is now acting on an area of BW into XU. Oh, sir, no? BW into XU. BW is this. Excuse me. Yes. Okay. So now it is acting on an area of, okay, now XU into BW. Okay, sir, now it is this. So now these CU force and TUW force and CUW force has got some distance, and this we call it as the lever arm. Lever arm can be written as D minus 0.42 XU because this distance is 0.42 XU. Am I right? So this lever arm can be written as D minus 0.42 XU. Am I right? So now this is now the explanation for stress block in web portion. Now I will come to stress block in the flange portion. Baba, in the flange portion means it is only this much. Okay, in sense this much flange and this much flange. This much portion we have already considered it. Okay, this much portion we have already considered it. Now it is this portion of the flange and this portion in the flange. Okay, see now this portion can be written, area is BF minus BW. Am I right? BF minus BW will give me this length and this length. Okay, into DF will give me this much area and this much area. Okay, see now that area of the stress block is now rectangular only now. So its stress is 0.45 FCK. Okay, and it is at the CG of this CUF force is now acting. At the CG of the steel, TUF force is now acting. Okay, so TUF I can write it as now FP into APF. APF is, it is the pre-stressing steel required for the flange portion. Okay, stress into area will give me TUF. Similarly, Baba, CUF is given as, Baba, average stress is 0.45 FCK and it is acting on an area of BF minus BW into DF. Okay, it is acting on an area of this much plus this much. This area is BF minus BW will give me this length and this length into DF will give me this much area into plus this much area. Okay, so stress into area will give me CUF force. Was that no? So this is how the stress block in the flange portion can be written. Okay, see now. So now from the statics I can write TUF for equilibrium. I can write TUF is equal to CUF. In a sense, TUF should be equal to CUF. Baba, I know TUF. You can write as now FP into FPF. Okay, same thing you have written. CUF also you know. Here you have written the same thing I have written here now. 0.45 FCK into BF minus BW into DF. Okay, so now from this equation I can calculate APF. In the sense, area of pre-stressing force, pre-stressing cable required for the flange portion. Okay, so FP will come here now. It is 0.45 FCK BF minus BW as it is, DF by FP. This FP I have taken it now here now. So from this equation I can calculate APF. Okay, so once you know APF, what's that now? In a sense, area of pre-stressing steel required for the flange portion. So now I can easily calculate, once I know this APF, I can calculate APW, pre-stressing area required for the web portion. It is the total AP minus APF will give me APW. Okay, so now once I know this APW and APF, now I can calculate the ultimate moment of resistance MU. Baba, ultimate moment of resistance is given by, Baba, it is the moment of resistance due to the web portion plus the moment of resistance due to the flange portion. TUW into A. See now, TUW into lever arm will give me the moment of resistance for the web portion. TUF into lever arm A will give me the moment of resistance for the flange portion. Baba, same thing I have written, TUW into A plus TUF into A. Okay, but TUW or TUW into A, instead of TUF I can write a CUF because TUF and CUF are equal. Okay, so now here instead of TUW I can write FPW into APW. Instead of A I can write D minus 0.42 XU. Instead of CUF, equation is now here. I am going to fill that equation here now. A lever arm also I know it is so much. So now from this equation I can calculate the moment of ultimate moment of resistance of this. Baba, FPU can be XU, they are calculated again by using this table number 11. Okay, how to use this table number 11 given in your IS code, that we shall see in the problem itself. Okay, so now this is how we analyze the beams, either flange section or rectangular section, for its ultimate moment of resistance. Okay, thank you very much.